This video explains the key differences between the RF power amplifier and the low noise amplifier. We will compare their roles in the transmitter and receiver, their signal level handling, noise performance, and their impact on overall system SNR. We start with the first key aspect, their position in the communication system. The power amplifier is located in the transmitter, just before the antenna. Its role is to boost the RF signal before it is sent into free space. The low noise amplifier is located in the receiver, right after the antenna. Its job is to amplify the very weak signals coming from the antenna while adding minimal noise. So, this leads to a fundamental split in their roles. The PA is responsible for transmission, while the LNA is responsible for reception. Building on this, the next key aspect is signal level handling, where we see how PA and LNA work with completely different signal strengths in the RF chain. In the transmitter, the signal from the modulator is relatively small, usually at the milliwatt level. The power amplifier increases this signal to a high power level, often in watts, so it can travel through free space, overcome path loss, and reach the receiver. That is why the PA sits at the final output stage. At the receiver side, the signal from the antenna is extremely weak, in the microvolt to millivolt range, and easily buried in noise. The low noise amplifier amplifies this weak signal right after the antenna while adding minimal noise, preserving the useful information. That's why the LNA is placed at the front end. So the key idea is simple. PA boosts a relatively stronger signal for transmission, while LNA boosts a very weak signal for reception without degrading it. In short, PA handles power delivery and LNA handles signal recovery from noise. To better understand why PA and LNA are designed so differently, we need to look at their core design priorities. For the power amplifier, the main goal is to maximize power delivery to the antenna while maintaining high efficiency. Since it operates at high power levels, heat generation and power handling become critical design constraints, so PA is essentially focused on energy efficiency. On the other hand, the low noise amplifier has a completely different focus. Its main priority is to minimize added noise, preserve very weak incoming signals, and improve receiver sensitivity. So, LNA is fundamentally about noise minimization. A simple way to remember this is, the PA is like a powerful loudspeaker that pushes sound far efficiently, while the LNA is like a studio microphone preamp that keeps tiny signals clean and noise-free. The next key difference between PA and LNA comes from what each of them is trying to achieve in the communication link. The power amplifier mainly focuses on pushing signals farther into space. By increasing transmit power, it directly extends the communication range and overall system coverage. In contrast, the low noise amplifier focuses on recovering extremely weak signals from noise at the receiver side. Its role is to make sure even very small incoming signals can still be detected and processed correctly, enabling reliable reception. A simple example is two walkie-talkies. A stronger PA lets your voice travel farther, while a better LNA helps the other person hear weak signals more clearly. In reality, both are essential. PA improves transmission strength, and LNA improves receiving capability. Finally, the impact on SNR is different for PA and LNA. The PA affects SNR indirectly. By increasing transmit power, it can improve the received signal strength, which may increase SNR. However, if the PA operates non-linearly, it generates distortion, harmonics, and unwanted interference, which can degrade signal quality and reduce SNR. So, its effect on SNR comes from both transmit power and distortion behavior. In contrast, the LNA directly affects SNR. It is the first block after the antenna and works with extremely weak signals. If the LNA adds too much noise, the signal quality is degraded immediately, and later stages cannot recover the lost SNR. That is why a low noise figure is critical. A good LNA preserves weak signals, maintains high SNR, and improves receiver sensitivity. To summarize these 5 key aspects, PA and LNA play completely opposite but complementary roles in an RF system. The PA operates on the transmitter side, handling high-power signals, focusing on efficiency, and determining transmission range, while affecting SNR indirectly. In contrast, the LNA works at the receiver front end, dealing with extremely weak signals, focusing on low noise and sensitivity, and directly impacting SNR and detection capability. Together, they define how far we can transmit and how well we can receive in a communication system. Hope this video helped you understand the key differences between these two types. Thanks for watching, see you in the next video, and don't forget to like and subscribe.